Today, we will be finding the shortest distance between a point and a line. In a three-dimensional space. So, I'm going to show you the formula first. So, the minimum distance is equal to the vector v crossed with p null q. The vector p null q. And I'll show you what each of these represent first after I write this formula. But the vector v is the vector that is parallel to the line. And let's say we have some miscellaneous line 1, 2, 3 plus t of 1, 2, 3. V for this equation is the vector that is parallel to the line, which is this one right here. Oh. And P of Q is P null is any point that is on the line. So typically in this format for representing a line in 3D, this will be any point on the line that you will use. And Q will be the point that you are trying to find. So Q, let's say it's like 1, 2, 5 or something. This will be the point that you are trying to find the distance of. And what I mean by that is, let's draw a graph. Let's say you have a line, and this is just going to be in 2D for easier representation. But right here is point Q, and 1, 2, 3, I don't know, some random point. Let's say this is P null. And this right here, this vector, is P null Q. And then any vector that is parallel, like this one, to the red line is V, is vector V inside of this formula. And for this, we're actually trying to find the distance between here, this point Q, and the line. And the shortest path between Q and a line will be anything that's just straight towards the line like this. So any straight way towards the line, and we are finding this distance here, d min. Hold up. Let me clarify one extra point, by the way. The reason why this is the shortest path to this line, if you're confused on anything, is because if you go, I don't know, you try to find this distance between this point on the line and point Q, well, obviously this is longer than this guy right over here. This is obviously longer. You try to draw it from here to here. This will be longer than d min. Just this line right here, d min, will form a perpendicular line with the red line. That's the shortest path. So we'll go ahead and do some practice problems. That's the best way to find out how to do something. So I'm going to start it off by giving you a point. Let's change the color. A point 1, 2, and, well, 3. And I'm also going to give you the x, y, and z values for the function. So 1 minus t, and z is equal to 3 plus 2t. So go ahead and try to solve this with this formula. And remember, vector v is the line that is parallel, is the vector that is parallel to the line. P is the point on, is any point on the line, and q is the point you are trying to find. So in this example, let me give you a hint. This would be the q for the formula. This right here would be the q for the formula, but I just named it p. So I'm going to change this format into whatever the vector format. I don't know what it's called. It doesn't matter what name it is. But let's change it to the vector format that you are more familiar with. This would be 0. This would be 1. And this would be 3. Plus t of 2, -1, and this is 2. So this is the line, or the vector equation of the line. I think that's what it was called. And we are going to try to find P of Q first. So P of Q here would technically be this. So let's this point to this point. So we'll try to solve that, and I'll actually change the names for just easier understanding. So we'll change this to PQ, and we'll just write down a P null up above here. So the vector to P null and Q is 1, 1, and 0. And the vector V is just the vector that is, let's write this above the PQ. Vector V is this vector here that is parallel to the line. So we can just copy it down. And once we have this, we'll solve for the cross product of vector V and P null Q. So this is P null and this is Q. And we're going to solve for the cross product between vector V and P null Q. So the cross product here would be, and if you don't know how to solve cross products, I highly recommend that you figure it out. I have a video on that actually, so if you are confused about them still, I have a trick that I use that is somewhat easier than just memorizing the formula. But memorizing the formula is also another way that you can solve for cross products, but let me just go ahead and solve this. -1 times 0 is 0. 2 times 1 is 2. 2 times 1 is 2. Minus 0. 2 plus 1. So this is the cross product of vector V and PQ, and we'll just set this equal to, simplify all this to -2, 2, and 3. Once we have this is the cross product. We have to find the magnitude. So how do you find the magnitude? Just square root all the values and square all the values and add them. So the reason why I'm not putting -2 here instead is because anything squared will always be positive. So it doesn't matter if I leave it negative or positive. I just turn it all to positive, and the result will still be the same. The numbers all to positive. Result will all be the same. So square root of this is equal to 4 plus 4 plus 9, which is square root of 17. And then once we have that, we have the magnitude of vector V cross PQ in this formula. Now we just have to solve for the magnitude of vector V. So the magnitude of vector V, let's do that up here. So the magnitude of vector V is equal to the square root of, and where's vector V? Over here. Square root of 2 squared plus 1 squared plus 0. No, 2 squared. And this is equal to the square root of 9, which is equal to 3. So we just plug in all of our values. So square root of 17 goes on top because we solve for square root of 17 as the magnitude of these two cross products. So we put that at the top of the formula, and then we just fill in 3 down at the bottom. So for this problem, you'll be given a point that is not on the line. So you're trying to find the distance between this point here. And these are 2 points on the line. So I'm not giving you the equation for the line. And I'm not giving you any of the values. These are just 2 points on the line. You have to figure out the equation given these 2 values. And then once you figure out the the equation of the line, then find the distance between this point and the line. So go ahead and try to solve this. And then come back when you're stuck or when you think you saw the answer. So I'm going to start off by finding the vector between Q and R, which would be the vector that is parallel to the line given here. So the vector Q to R is 2, 2, and -1. So this would be the vector that is parallel to the line here. And then any point on the line, let's just use Q here, 1, 0, and 1. So the function for this line would be 1, 0, 1 plus t of the vector that is parallel to the line. And this is what we would get. So now that we have this, we can mark off the names of our whatever is related to the function, or whatever, like, I guess, values you use. So it just is easier once you plug things in that you won't get confused between the variable names. So like, let's say you had like q null p instead. That'd be a little weird to plug in. Maybe you can make a mistake there. So I just recommend keeping it consistent, the names of the variables and the names of the vectors consistent with the formulas that you are using. So the vector that is parallel to this line is 2, 2, and -1. We're just grabbing it from up here. And the point P and Q. So a point on the line, the vector between the point on the line, which is P null, and the vector between the the vector between the point on the line and the point we're trying to find. There you go. That's right. So this vector would be from Q to P. Same thing as P null and Q for this formula. We just switch the names. This is P null in our representation in the formula, and this is Q in our representation in the formula. Don't get it mixed up. It's a little confusing. So P null is 1, 0, 1, and we're trying to find the vector between 1, 0, 1 and 4, -1 and 2. So let's go ahead and do that. 3, -1, and 1. There you go. And then let's just, all we have to do is find the cross product of V and P null Q. So let's find the cross product here. 2 minus 1 -3 minus 2 and -2 minus 6. And this is equal to 1, -5, and -8. Let's go ahead and find the magnitude of this, but let's just set this equal to, we don't even need to find it. We don't even need to show the name. Let's find the magnitude of this. 1 squared, 5 squared, 8 squared is equal to the square root of 90. You can simplify this to be 3 square root of 10. And then let's go ahead and find the magnitude of vector v. So the magnitude of vector v is equal to the square root of vector v is here, 2, 2, and 1. So 2 squared plus 2 squared plus 1 squared is equal to the square root of 9, which is equal to 3. So we put our values, or we substitute it into the formula, and we get 3 square root of 10 over 3, which is equal to the square root of 10, which is the minimum distance between point P and the line Q and R. So for this problem, you're actually given the equation of the line, which is a lot easier now. You just for any like problem, I guess, that you have to find the distance between a point and a line, this format will probably be the easiest to figure out or do the math with. So try to get it into this format. If you can't, I mean, like, you can still work out the problem, just going to be a little more annoying. So the vector v, which is parallel to the line, let's start naming it, is 2, -1, and 1. And I got that from here, by the way. This is the vector that's parallel to the line. I keep accidentally deleting things. And P null of Q, which is any point on the line, so the vector between any point on the line, which is usually this one, to the point we are trying to solve the distance for, which is this one. So vector between this green one and this. And that vector would be 4, -4, and -2. Let's go ahead and find the cross products of these. The cross product would be 2 plus 4, 4 plus 4, and It's the last one. -8 minus, is it minus? It's -8 plus 4. And this turns out to be 6, 8, and -4. Let's go ahead, and this is the cross product between vector v and q, pq. P null of q. Let's go ahead and find the magnitude of this. The magnitude would be the square root of 6 squared plus 8 squared plus 4 squared, because those are the components of this vector, and we're just going to find the magnitudes of all of these, which is equal to 106, square root of 116. Go ahead and find the magnitude of vector v. This is equal to 2 squared plus 1 squared plus 1 squared. Vector v is this. We grab 2 and pull it down here. -1, pull it down here. 1, pull it down there. This would turns out to be 4 plus 1 plus 1 is 6. So we just plug in all these values. We have the cross product here, the magnitude of the cross products between these two vectors, and we also have the magnitude of the vector that is parallel to the line. Plug in all these values. We get 116 over square root of 6. And this right here, unsimplified, but this is the d-min. So thanks for watching. If you have any questions, put it down in the comment section. If you want me to cover anything specific in your Calculus 3 class that my class didn't cover, please let me know, because I would love to learn about that and make a video about it.